This is a star in a state of violent self-destruction. Its outer atmosphere is being torn apart by its own radiation, surging outward at speeds of thousands of kilometers per second. The stellar body is visibly shrinking on a cosmic scale. It is a rare celestial object known as a Wolf-Rayet star. In a galaxy of 200 billion stars, fewer than 1,000 are Wolf-Rayets. They are rare because they occupy a fleeting, terminal stage of life, embarking on a path of no return from the moment they are born. While ordinary stars maintain a delicate balance for billions of years, a Wolf-Rayet star is defined by its total loss of equilibrium. Its existence is a predestined countdown to a cosmic collapse. To become a Wolf-Rayet, the first requirement is extreme mass. A progenitor star must be at least 20 to 25 times the mass of our Sun. In some cases, they evolve from hypergiants exceeding 40 solar masses. Without this heavyweight ticket, a star cannot enter this volatile path. The journey is a brutal, multi-step process of mass shedding. Step 1 begins during the main sequence, the star's prime. For the Sun, this is 10 billion years of stable hydrogen burning. But for these monsters, stability is an illusion from the start. With core temperatures reaching upwards of 40 million Kelvin, radiation pressure relentlessly pushes stellar material into space. Before it even reaches middle age, the star is already leaking mass. Step 2, the transition into a red supergiant. The star's radius swells to over 1,000 times that of the Sun. If placed at the center of our solar system, it would engulf Jupiter. This massive expansion marks the beginning of the onion peeling phase. The outer hydrogen envelope is shed in violent, massive eruptive events. Powerful stellar winds blow away entire layers of the star's atmosphere. Step 3, the total stripping of the hydrogen layer. When the hydrogen is gone, the bare helium core is finally exposed. This is the official birth or debut of a Wolf-Rayet star. What remains is essentially a naked core, stripped of its outer raiment. You are no longer looking at a full star, but its exposed internal engine. Modern astrophysics shows that nearly half of these stars don't do this alone. In binary systems, the gravity of a companion star acts like a siphon, physically tearing the hydrogen envelope away from the primary star. This interaction can accelerate the transition by more than tenfold. Once the skinning is complete, the remaining core becomes a Wolf-Rayet. Every stage of this evolutionary chain is irreversible. The envelope, once lost to the void, can never be regained. It is a one-way cosmic highway with no U-turns. The fate of this star was written millions of years in the past, encoded in the extreme mass it held at the moment of its creation. As we look deeper, we find that the light from these stars tells a story. A story that began with a mysterious discovery in 1867. At the Paris Observatory, Charles Wolf and Wolf-Rayet noticed something. Something that defied the established laws of physics of their time. Instead of dark absorption lines, they saw broad, brilliant emission bands. This was the first proof of a star leaking its own essence into the dark. A phenomenon that would baffle scientists for the next 60 years. How could matter move so fast without the star exploding? The answer lay in a limit that no star is supposed to cross. But the Wolf-Rayet star lives its entire life beyond that edge. It is the ultimate rebel of the cosmos, burning too bright to last. As we reach the 4-minute mark of this journey, we see only the beginning. The true chaos is yet to be revealed in the heart of the nebula. This is Greetings from the Abyss. Chapter 2, The Seekers of Light. Our modern understanding of these cosmic rebels began in 1867, at the historic Paris Observatory under the dark skies of the 19th century. Two French astronomers, Charles Wolf and Wolf-Rayet, pointed the 40-centimeter Foucault reflector telescope toward the Swan. They were observing three mysterious stars in the constellation Cygnus. At that time, Kirchhoff's laws of spectroscopy were the gold standard. Most stars showed Fraunhofer lines, dark absorption gaps created by cooler gases in the stellar atmosphere filtering the light. But as Wolf and Rayet peered through their spectroscope, they encountered a phenomenon that defied convention. Instead of the expected dark lines, they saw brilliant, luminous bands. These were emission lines, glowing signatures of superheated gas surrounding the star, radiating energy directly into space. The presence of these broad, bright bands was unprecedented. It suggested a star not in equilibrium, but in a state of violent outflow. Their discovery, published in the Comptes Rendus of the French Academy, introduced the world to a new class of spectral anomalies. Stars that were literally bearing their souls through their light. But as they marveled at these bright lines, a new question emerged. The width of these bands hinted at a velocity so extreme, it seemed to break the very laws of physics known to the 1800s. Welcome to the mystery of the Wolf-Rayet speed. Dua de la don fuda.srt Bangsheng on Chofan don 518-612, Bat Dau 2 so Thursday 281. Toida tik hop kak kanyem koa hok new Doppler broadening, Sujian rong Doppler, de jathich tai sao kak vach sang lai rong, va dua ra kak so san tuk te de lam noi bat sukin engak kwajoy koa hok the ky19. Don ma 8100:005:00-00-05:21,500. But the real shock came when they analyzed the shape of these lines. In a typical star, spectral lines are sharp and well defined. However, the emission bands of Wolf-Rayet stars were incredibly broad. Through the lens of the Doppler effect, this width told a terrifying story. It indicated that the gas was not static, but screaming away from the star at velocities ranging from 1,000 to over 3,000 kilometers per second. To the scientists of 1867, these numbers were utterly impossible. At such speeds, you could travel from the Earth to the Moon in 2 minutes. No known physical mechanism of the time could explain this power. Gravity should have held the gas back, yet something was winning the tug of war. It wasn't a simple explosion, but a continuous, violent outward flood. How could a star sustain such a massive loss of material without vanishing? The discovery stood as a lonely paradox in the annals of astronomy. A mystery so profound that it challenged the very foundations of 19th-century thermodynamics and celestial mechanics. Following the 1867 discovery, a profound silence fell over the field. For over half a century, these stars remained a scientific dead end. Astronomers could catalog them, but they lacked the tools to decode them. Classic 19th century physics could not bridge the gap between the observed light and the extreme physical reality of the star. The enigma had to wait for the birth of a new era, the quantum age. It wasn't until the 1920s that modern stellar astrophysics was born. With the pioneering work of Cecilia Payne-Gaposchkin in 1925, we finally understood that stars were composed primarily of light gases. Simultaneously, the development of the theory of radiative transfer revealed how light itself could physically push against matter. This 60-year hiatus was a testament to how far ahead of their time Wolf and Rayet truly were when they peered through their telescope. The silence ended when we realized these were not broken stars, but the ultimate laboratories of high-energy physics. Chapter 3, Breaking the Laws of Physics. In every stable star, a silent tug of war maintains its existence. This is hydrostatic equilibrium, the delicate balance between gravity pulling inward and radiation pressure pushing outward. But in 1926, Sir Arthur Eddington calculated a theoretical ceiling, now famously known as the Eddington Limit. He discovered that there is a maximum luminosity a star can reach before its radiation pressure becomes stronger than its gravity. Once this limit is breached, the star can no longer hold itself together. The outward flow of photons literally lifts the outer layers of gas, stripping the star bare and launching it into the interstellar void. Wolf-Rayet stars are unique because they exist at this very edge. They are super Eddington objects, stars so luminous and massive that their own light acts as a catalyst for their disintegration. Eddington's math in 1926 finally provided the framework we needed to understand why these giants bleed mass at such terrifying rates. They are stars that have officially outshone the laws of stability. To visualize this, imagine a high-performance engine. A Wolf-Rayet star is like a car with its needle permanently stuck on the red line. It operates at maximum output, pushing its physical limits every second. But unlike a short-lived explosion, this star maintains this extreme state for hundreds of thousands, even millions of years. The result is a phenomenon known as sustained stellar mass loss. Every single year, a Wolf-Rayet star sheds enough material to equal the mass of 10,000 Earths, or even more. It is not a sudden supernova, not yet, but a continuous, unrelenting leakage of its very essence into the interstellar medium. This mass loss is driven by a wind so powerful it outshines the sun by a factor of hundreds of thousands in terms of kinetic energy. As the star bleeds its outer layers, it reveals the heavy elements cooked deep within its core: carbon, nitrogen, and oxygen. It is a slow-motion suicide, a magnificent unraveling of one of the most massive structures allowed by the laws of nature. A giant that chooses to burn out rather than simply fade away. For decades, these stars remained hidden behind a veil of their own making. The dense stellar winds act like a thick cosmic fog, scattering visible light and obscuring the star's true nature. To understand them, we had to change the eyes of humanity. The breakthrough arrived in the 1960s with the dawn of multi-wavelength astronomy. By looking through the lenses of radio and X-ray observatories, we finally bypassed the opaque shells of hydrogen and dust. Radio telescopes revealed the massive, ionized nebulae carved out by the star's relentless kinetic energy over eons. Even more shocking was the data captured in the X-ray spectrum. Satellites detected high-energy emissions originating from shock zones where stellar winds collide at velocities of millions of miles per hour. In these regions, plasma is heated to staggering temperatures of 10 million Kelvin. At this heat, matter no longer behaves like a gas, but as a glowing fluid that emits X-rays through a process known as thermal Bremsstrahlung. Modern observatories like Chandra and XMM Newton have since mapped these violent envelopes, showing us the star's breath in vivid detail. We are no longer limited by what our eyes can see, but by what our mathematics and technology can reconstruct from the invisible spectrum. The Wolf-Rayet star is no longer a ghost, but a beacon of high-energy physics, shining brighter in the dark than ever before. Chapter 4: The Remaining Secrets, Death Dance and Nuclear Forges. A Wolf-Rayet star is rarely a solitary suicide. In the vastness of the cosmos, they often engage in a death dance with a massive stellar companion. Astrophysical data suggests that nearly 70% of high-mass stars do not live alone, but exist in binary systems. In these pairings, gravity is no longer a force of simple attraction, it becomes a razor-sharp blade, stripping the outer layers of one star to expose the burning, nuclear core hidden within. The primary mechanism for this is known as Roche lobe overflow. As the more massive star evolves and expands, it reaches a limit, the Roche lobe, where its material is no longer bound by its own gravity. The companion star acts like a cosmic siphon, vacuuming the gas and accelerating the transformation into a Wolf-Rayet state thousands of times faster than a single star would. This mass transfer is a chaotic exchange of angular momentum, shaping the evolution of the entire system toward a violent end. But the dance becomes even more spectacular when both stars are giants. These are colliding wind binaries, where two powerful stellar winds clash head-on at velocities of millions of miles per hour. This collision compresses gas and cools it into carbon-rich dust, creating a stunning phenomenon known as a dusty pinwheel. The most iconic example is the WR-104 system, located 7,500 light-years away. The interaction creates a perfect spiral of dust, rotating like a celestial lawn sprinkler, marking the path of the star's orbit across the void. This dust is not just beautiful, it is the raw material of future worlds, cast out into the galaxy by the very force of the star's destruction. As the orbit tightens, the energy released in these shocks becomes gargantuan, emitting high-energy particles that can be detected across the universe. In this binary struggle, we witness the ultimate paradox of nature, a partnership that accelerates the demise of both participants. They are bound together by gravity, only to be torn apart by radiation. As we reach 15 minutes of this odyssey, we prepare to enter the forge itself. The place where the elements of life are forged in the fires of death. Next, we explore how a dying star becomes the ancestor of your very atoms. Step into the ultimate forge of the cosmos, the stellar core. Here, under pressures and temperatures that defy imagination, the elements of life are being hammered into existence. Wolf-Rayet stars are classified into 3 sequences, WN, WC, and WO. These are not just labels, they represent a deep look into the star's guts, revealing which nuclear furnace is currently burning brightest. First, we encounter the WN sequence stars rich in nitrogen. In these giants, the CNO cycle of hydrogen fusion is dominant. As the outer hydrogen layers are stripped away by violent stellar winds, the byproduct of this cycle, nitrogen, is exposed to our telescopes. It is a signature of a star that has lost its youth but is still fighting. Next is the WC sequence, where carbon becomes the dominant feature. Once the WN layers are blown off, we see the triple alpha process at work. Helium nuclei are fused together to create the very carbon that forms the structural backbone of all organic life on Earth. Finally, there is the WO sequence, the rarest and most extreme. These stars are rich in oxygen, signaling the start of carbon burning. A WO star is a cosmic siren, warning that its final collapse and eventual supernova are only a few thousand years away. Think about the atoms in your own body, the carbon in your DNA, and the oxygen in every breath you take. A vast portion of these elements was forged in the fire of Wolf-Rayet stars. By shedding their mass through powerful winds of life, they seed the galaxy with the ingredients for future planets. We are quite literally the ash of these brilliant, dying suns. As the clock ticks toward 20 minutes, the star's fuel begins to fail. The final roar is approaching, the moment when the forge goes cold, and the giant finally falls under its own massive weight. Every star has a final chapter, but for a Wolf-Rayet, it is a scream. As the internal pressure fails, the core can no longer resist gravity. The result is a cataclysmic event unlike any other, a clean supernova. Most massive stars die as Type II supernovae, leaving a trail of hydrogen. But because Wolf-Rayet stars have already shed their hydrogen envelopes, they explode as Type IB or Type IC supernovae. In the spectroscope, these explosions appear stripped devoid of hydrogen, representing the raw, naked collapse of a heavy metal core. However, if the star is rotating rapidly, a darker fate awaits. This is the collapsar model, where the core collapses directly into a black hole. The dying star's angular momentum focuses energy into 2 narrow jets, erupting into a long-duration gamma-ray burst, GRB. A GRB is the most powerful electromagnetic event in the universe, releasing more energy in seconds than our sun will in its entire lifetime. Such a beam could sterilize a galaxy across thousands of light years. Look at the stunning image of WR-124 captured by the James Webb Telescope. What looks like a beautiful flower of gas is actually a chaotic halo, a portrait of a giant standing at the very edge of the abyss. Within a cosmic blink of an eye, this beauty will turn into a blinding flash, leaving behind only a remnant or a silent, hungry gravitational well. The final roar of a Wolf-Rayet is a signal of both death and rebirth, scattering the heavy elements of the forge into the deep dark. As the dust settles, we realize that without this roar, we would not exist. Conclusion: the testament of the stars. We often perceive the night sky as a static, eternal masterpiece. But in reality, it is a dynamic scene changing in real time. The reason it feels still is simply because the scales of cosmic time vastly exceed the narrow window of human perception. What is a million years to a star like a Wolf-Rayet? It is a fleeting moment, a brief spark in the dark. Every point of light you see tonight has its own countdown. Every star is marching toward its own inevitable finish line. The brief but brilliant existence of the Wolf-Rayet star reminds us of a fundamental truth: the universe wastes nothing. This is the grand cycle of cosmic recycling. The death of a massive star is the fertile soil of the next generation. Without their violent ends, there would be no rocky planets, no Earth, and no life to contemplate the heavens. As the great attractor pulls us forward into the unknown, we carry the legacy of these giants within our very cells. The next time you look up, remember, you aren't just looking at light. You are looking at the ancient forges that created your atoms. We are the descendants of those who chose to burn brightly in the abyss. Thank you for joining us on this journey through the life of the Wolf-Rayet. Subscribe to Nok Lik Studio to continue exploring the universe and uncovering the fascinating secrets of our cosmic origin. I am Nok Lik, and the universe is waiting for you. Until next time, keep looking up. Stay with us as we witness the dramatic end of the Wolf-Rayet.